But I just recorded 2.2, which is atmospheric pressure, and it got deleted, and I don't know how. So I'm going to explain that again. Oh man. Oh man. Okay, at least I didn't erase the notes. Okay, so atmospheric pressure is the definition of atmospheric pressure is the pressure due to the weight of the layer of air acting on the surface of the earth. So basically in the air of the atmosphere, there is air molecules, and air molecules has mass. Anything with mass has weight, and weight is a type of force. So the pressure due to the weight of the air in the atmosphere is that force is acting towards the surface of the earth. So that is atmospheric pressure. The force acting on the surface of the earth by the air molecules in the atmosphere. So there are three instruments we can use to measure atmospheric pressure. The first one is mercury barometer. We can see right here, it has mercury, it has vacuum. So the height of the mercury column, which is this is the mercury column, at sea level, the height of mercury column is 760 millimeters, which is also 76 cm. And when the atmospheric pressure increase, the height of the mercury column also increase. If the pressure of the atmospheric pressure decrease, then the mercury column, the height is decreased. Now the aneroid barometer. Aneroid barometer is this round one, small round. 14 barometer is this big and long one. Aneroid barometer, how it gives a reading, it changes the volume of the partial volume. Change the volume of partial vacuum metal box. So basically it changes the size. While the 14 barometer, it changes the height of the mercury column, and the mercury column is here in the middle. The aneroid barometer is small and portable, so you can easily bring it, while the 14 barometer is really large and long, and it is not portable at all. The aneroid barometer gives a direct reading, while the 14 barometer takes longer time to give reading. But even though aneroid barometer so far sounds really good, it gives a lower accuracy by plus minus 1 millimeter mercury. But the 14 meter, it gives a higher accuracy, which is plus minus 0.1 millimeter mercury. Okay. Units for pressure. So the first one here, Pascal. The second one here, millimeter Hg. The third one, meter H2O, and the last one is mbar. The millimeter Hg means that at 1 millimeter inside mercury, the pressure is 1 millimeter Hg. And in meter H2O, it means that 1 meter in the water is 1 meter H2O. That is the pressure. So P equals to rho H rho G. We can convert it into Pascal. While m bar is much different. One m bar is 1 HPa, which means 1 times 10 to the power of negative 3, because it's milli, is 1 times 10 to the power of negative 3 bar is equals to 1 times 10 to the power of 2 Pascal. So if we convert it, 1 bar is equals to 1 times 10 to the power of 5 Pa, which is the atmospheric pressure. So now we're going to start with the next concept, which is gas pressure. Gas pressure can be measured by an instrument called the manometer. Okay, so I have 3 YouTube here. Ignore my ugly handwriting, I'm trying to be quick. Okay, so this one is before it's connected to a gas supply. So I have liquid in here, and the pressure that is experienced by it is the atmospheric pressure. So it's equal. Since it's equal, it is at the same level. Same pressure means same level. Now for the second picture and the third picture is after connected by the gas supply. This is the first situation. Let's say the gas is at higher pressure. So since the gas is higher pressure than atmospheric pressure, then it will push the liquid down like this. So this is A, this is B. The higher pressure, it pushes the liquid down because it is much higher than the atmospheric pressure. So you can calculate the pressure of gas by using the pressure ATM plus pressure liquid. Okay, so this is PL. How come can become like this? Because PL is equals to how come it's like this? It's because It's because PL is equals to pressure gas minus pressure ATM. Because the ATM is smaller than the pressure gas. So what if, in the second situation, the pressure is lower and the atmospheric pressure is higher? So the water or the liquid at the atmospheric pressure, since it's higher, it will push the pressure down and it will push this part up. So this is A, this is B, this is our PL. So for this one, we calculate it with PATM equals to P gas plus PL. Why? Because PL is equals to PATM minus P gas. Honestly, I find it easier to use this one than the one above because we can see which one is much higher pressure. For example, this one PATM is higher pressure, so PATM will be in the front. This one, the gas pressure is much higher, so the P gas will be in the front. Okay, example question. So I have this YouTube with gas supplied. Okay, so a compressed gas is connected to a mercury manometer. Calculate the difference between gas pressure and the atmospheric pressure in cmHg. So the gas pressure here and the atmospheric pressure is here. So in cmHg, it means is 1 cm is 1 cmHd. Oh. So it means we already got this length here. So the difference here and here, the difference is 12 cm. So the answer is 12 cmHg. The second question is the gas pressure in cmHg. So you can see, the pressure here is actually higher because this is lower than this one. So that means this one is a higher pressure and this one is a lower pressure. So we can use the formula P. I'm gonna use the formula I like. PL equals to P gas minus P ATM, because the pressure of gas is lesser than P ATM. So if we move, this ATM to here, it will become P ATM plus PL. So the P gas, it will be that. Because we learned before this that atmospheric pressure in mmHg is 706. So if it's cmHg, then it's 76. So that is the P ATM. And then our PL is this here, just 12 cmHg. So our gas pressure in cmHg is 88 cmHg. Now we need to find the gas pressure in PA. So the gas pressure in CA. So P gas equals to H rho J. Since it's liquid, you can use the liquid formula. So our H is 0.88 because we convert the cm into meter. The rho for mercury is 1.36 times 10 to the power 4. This is given in the question. So 1.36 times 10 to the power 4 times by the gravitational acceleration, which is 9.81. And the answer we get is 117406.08 PA. The next question is, a compressed gas is connected to a mercury manometer. If the gas pressure is 85 cmHg, what is the value of H? So gas pressure here, they say, is 85 cmHg. Okay, so the atmospheric pressure, oh, no. Hold on. Well, what is the value of H? Oops, I forgot to write. Okay, this is H. So we need to find the value of H. So what we know is that the PATM is equal to 76 cmHg. So that means over here is 76 cmHg. So we can find H by subtracting these two values together, because the pressure here is much higher than the atmospheric pressure. So H is equals to 85 minus 76, and the answer will be 9 cm. The next question is, what will happen if the value of H if mercury is replaced with water? So, the pressure of gas is equals to H rho G. So this one is in mercury. So 0.85, because this is in cm, we need to change it in meter. So 0.85 times by the density of mercury. So the density of mercury is this, which will be given in the exam, 1.36 times 10 to the power 4 times with the G, which is 9.81. So the answer we will get is 113,403.6 PA. Now, the gas pressure H rho G, but inside water, because they asked what will happen to the value of H if mercury is replaced with water. So the gas pressure we got is here, 113,403.6 equals to the H, which is what we will look for. The rho is 1000 kg per meter cube. So 1000 times with 9.81. So the answer we will get is 1.56 mH2O. So in cm H2O, it will be 1. In cm H2O, it will be 1.5. It will be 1156 meter. Sorry, cm H2O. So the difference in H, we're gonna find it the same way here, since the PATM is also equals to 1000 cm H2O. So the H is equals to 1156. Sorry, it's not the H. The difference in H, 1156 minus 1000 equals to 156 cm. So therefore, the H will increase when the mercury is replaced by water. That is all for this video. I'll see you in the next one. Thank you for watching.